Hey folks, so welcome to the first of our physics power up workouts, and the idea of these is to go over specific topics and key areas, focusing on how to do calculations and also exam questions. Now, these revisions are not meant to cover every single thing about a topic. It's meant to focus in on the things that I tend to find people struggle with, or that you might need to know very well for your exams or to answer questions. So the very first one we're going to do is uncertainties, which is very well self-contained and fairly straightforward compared to some of the other stuff you've done in the course. So what are the relevant knowledge required for this power up workout? Well, first of all, I'd expect you to know what a reading and a random uncertainty are and how they are absolute uncertainties. I would also expect you to be able to convert absolute uncertainties into percentage uncertainties. And the other thing I would expect to know is how to give the reading uncertainty if a meter is digital or analog. So those are very basic things I'd expect you to be able to do. What we're going to look at today is how to determine a dominant uncertainty, and we're going to look at how to calculate the mean of a set of results. Also going to expect you to understand that the mean is the best estimate of the true value of the quantity measured. So I won't spend too much time on that. We're really focusing on the calculations today. And then calculate the random uncertainty for a mean using this equation here. And remember, this equation is given in your relationship sheet, so it's not one that you have to remember. Let's look at some examples of how we do calculations for uncertainties. So I've made up some readings here, and supposing we're measuring the current in a circuit. So I've done 5 replicate values. And how do we calculate, first of all, the mean? Well, hopefully, as higher people, you would know you add all the numbers together and divide by 5. Now, the interesting bit is, what do we do with our answer? Because you'll notice the answer is 1.28. Now, uh, because it's an experimental result, and because you've taken your readings to one decimal place, we should really have the mean to the same number of decimal places, 1. So I would round the answer up to 1.3. Now, the reason for that is because your mean can't be more precise than your actual readings. Now, remember, precise has a very specific meaning in physics. It means the number of decimal places that you take your reading to. So if your reading is only to one decimal place, then your calculated values should also be the same. So this is why I would round it to one decimal place. A key thing to remember as well is units. Pupils tend to forget that, and this is where you can lose easy marks. So hopefully that kind of makes sense, folks. The random uncertainty, remember we calculate that using the equation max minus min over the number of readings. So the maximum value here is 1.5, the minimum value is 1.2, and we've got 5 readings, so we do this in our equation. And again, notice we get an answer that's to 2 decimal places, so I round that up to 1 to make sure it's the same as our readings here. And again, very important, remember to include your amps there. Finally, how do you do the percentage? Well, here I'm going to convert our random uncertainty for the mean into a percentage uncertainty. And here, remember, this is called the absolute uncertainty because it has the same units as the readings, whereas a percentage uncertainty, as the name tells you, has units of percent. So to get the percentage uncertainty, all we do is 0.1 divided by the actual reading and multiply by 100. And that gives us a percentage uncertainty of 7.7%. Now, let's try it yourself. So if you're not sure, replay the video and remind yourself how to do it. Pause the video just now, and then I'll show you the answers. So hopefully, although we've changed the readings to voltage rather than current, it's still the same routine, the same process. So the mean you would do by adding all your values, divide by 5. So again, notice it's to 2 decimal places, but we want it to 1. So I've rounded my answer up to 2.4. The random, again, you're using your equation from the relationship sheet, max minus minimum over the number of readings. And the maximum is 2.6 and the minimum is 2.3. And again, notice we have to round up our answer to 1 decimal place. The percentage is the absolute over the actual reading. So it's 0.1 over 2.4. And so this gives us 4.16%. Now in this case, it is to 2 decimal places. So I've rounded it to 1 decimal place to keep it consistent with all my other 3 readings. So how did you do on that? If you got that okay, brilliant, keep going with the video. If you didn't, wind it back and just review what we've covered to make sure you understand where everything came from. Okay, final example here, and we're doing height this time. And notice we're taking our readings to 2 decimal places. So again, pause the video and then have a go of it. I'll show you the answer in the next couple of seconds. And did you get the following answers here? So 1.5 meters, 0.02 meters, and the percentage is 1.3%. And remember, you must include units for your mean and your absolute uncertainties. Okay, so hopefully by this point you are pretty confident with it. Let's move on and look at the next bit, which is dominant uncertainties. So, given the following results for an experiment, which uncertainty should be taken as a dominant one? Now, why am I talking about dominant uncertainties? Well, the name itself kind of tells you if something is dominant, it means it's sort of in charge. It's sort of like the one that has the most influence or the most impact. So when we're trying to combine uncertainties, and I've made up an artificial example, the argument goes that the one which has the biggest uncertainty must have the biggest influence. So if we look at our calculations from before, we found the following percentage uncertainties. Now, why do we look at the percentage uncertainties and not the absolute uncertainties? Well, first of all, we're trying to compare uncertainties. And if you're comparing things, can we compare them if they are in different units? And the answer is no. It's a bit like saying, well, let's compare an apple to an orange. You can't really make that comparison because they are entirely different things. So this is one of the reasons why we have percentage uncertainties, because if everything is in percentage, it means they're in the same units and we can compare them. And looking at this, you can see our smallest percentage uncertainty is 1.3 and our largest is 7.7. So in this case, we can take the percentage uncertainty in the current as being the dominant one, and we can kind of ignore these two. And the argument being that this is the one, because it's the largest, will have the biggest influence. And that's how we determine the dominant uncertainties. It's by looking at the percentage uncertainties of the things we want to combine and picking the largest one out of the set. So, as always, let's try one ourselves. Okay, given the following results for an experiment, which uncertainty should be taken as the dominant one? Pause the video, have a wee go of it, and then play it again, and I'll show you the answer. So the first thing I hope you realise you had to do was to convert it into percentage uncertainties. And if you do that, we get the following percentage uncertainties. Now, hopefully you didn't fall into the trap of trying to just compare the absolute uncertainties. And you actually remembered you had to convert them into percentage uncertainties. So in this case here, the actual dominant uncertainty is 8%. So this would be the one that we would take as the overall uncertainty. If any of that wasn't clear, just rewind the video and then just review the concepts again. And finally, to summarize, and this is really important because it is to help you to revise, and you may decide to make this as part of your notes or into a flashcard, it's entirely up to you. But to calculate the mean, we did the so Before I show you the answers, try and write these out yourselves, because then that way you can really show yourself you've actually understood the concepts. So pause the video, try and write down what they mean, how to calculate the mean, the random uncertainty, the percentage uncertainty, and the dominant uncertainty. Okay, so here's the answers, folks. Sum of all values divided by the number of values, remember units. Formula given in the relationship sheet, but remember units. Percentage uncertainty would just be the absolute uncertainty divided by the reading times 100. And it's the largest percentage uncertainty for the dominant. And that's the end of our first Power Up physics workout. So I hope you find that useful. Give me some feedback if you can think of anything to improve on.